Well, hello, Precalculus class. We are ready to get back to inverse matrices. And so I know we kind of took yesterday off just multiplying matrices, but that's because when we're doing our work today, we will need to multiply. So I hope your multiplying skills are getting better and better every day. You guys have told me they're getting good, and that's great. But we'll also be having a test probably next week because then we go on spring break for 2 weeks and we really don't know what's up. But we're probably going to have a test next week, so hopefully your multiplying skills, which is usually one of the trickiest things, is doing okay. We are going to work with inverse matrices today. But funny, when I hold up this first example, you can go ahead and hit pause. You can write down all the things I have on this paper. But I don't see a matrix yet. And so if we're going to be using inverse matrices, number one, you can only find the inverse of a square matrix. I know I said that a few days ago with a determinant. You can only find a determinant of a square matrix. But if you have to find the determinant in order to find the inverse, you are going to have to actually have a square matrix to find an inverse. And this does not even look like a matrix. So if you notice, the first thing I said was write in matrix form. And so because there are two variables here, the first thing we're going to write is a 2 by 2 matrix. The next thing we're going to write is going to kind of help us realize how we get this 2 by 2 matrix. And that's because we're going to multiply it by something called the variable matrix. If you notice in both of these, there's x and y. And so if I took away that x and if I took away that y, you would see a pretty nice 2 by 2 matrix right there, negative 8, 8, 4, negative 6. And so guys, this is what I usually like to say. And I know this one is very specific for this problem. But the first matrix you write down involves only your coefficients. The second matrix, put your variables in a vertical column. And then your answer matrix is on the other side. So coefficients only, negative 8, 8, 4, negative 6. Variables only, x, y. Answers only, negative 8, 0. And so now there is only one thing here that is a square matrix. We're going to find the inverse of that square matrix, and then we're going to multiply it on both sides, of course, because this is a math class. Whatever we do on one side, we have to do the other side to find our solution. So our square matrix is the negative 8, 8, 4, negative 6. So I'm going to cross down. That gives me a 48, should be positive. Cross up, 4 times 8 is 32, also positive. But remember, we're supposed to switch the sign of that second one. So I'm going to end up getting 48 minus 32. I do the opposite of what I see. 48 minus 32 is 16. And so I'm going to write a 1/16 out in front. Originally, the other day, some people asked me, and it is okay. We could leave that 1/16 out in front. We could kind of distribute it. For today's example, I am going to distribute it because 8, 8, 4, and 6 are all can be reduced with 16. And it makes it a little bit easier if it's kind of inside our matrix when we're doing multiplication. I promise you too, the fraction part should work itself out because we should get decent answers for all of our questions. And so, let's see. We got to do our flip-flop. So we're going to flip the spots of the negative 8 and the negative 6. So negative 8 is first and negative 8 is last. We're going to keep the spots of the 8 and the 4, but both of those have to become negative. And like I said, because it's a pretty nice answer, I am going to distribute that 16. So 16, 6 reduces with 16 gives me 3 eighths. 8 is half of 16, 4 is a fourth of 16, and 8 is a half of 16. So hopefully you understand why I would tell you that this right here, is my inverse matrix. In all honesty, both of these work out, but this is a little bit nicer because we get rid of that ugly 16. At least they're smaller numbers. And so the other day, if you were doing this homework, I would have accepted either one of these as the inverse. But what we're doing today, I think it's going to be nicer if we use this one. We are supposed to multiply that on both sides, but please be careful. You cannot multiply a 2 by 1 by a 2 by 2. So when we use the inverse has to go first. So it gets to be a long sentence the first time, but I promise you it's pretty simple math and it works itself out. I am writing down the inverse matrix first. Okay, the very first thing I'm going to write down after I find it is the inverse matrix. I am then going to write this side of the equation. So I'm going to copy that down. Here comes my coefficient matrix. And then I'm writing down my variable matrix. So it's this same thing, just the inverse in front. On this one, it's a little bit shorter, but I got to write the inverse first because order-wise, that's the only way I can. So I wrote down my inverse matrix, and now I'm going to write down my answer matrix. I now have to multiply it a few times to find my answer, but I'm going to show you guys how quick and simple this kind of is, because we actually know what we should get if we multiply a matrix with its inverse. We did that the other day. It's what I call the identity. That's where you get 1, 0, 0, 1, or at least we should. So let's see, 3/8 times 8, they're both negative. It becomes positive. The 8's cancel out, so I get 3. Half of 4 is 2. It is a negative 2. So 3 minus 2 does give me 1. If I multiply negative 3/8 with 8, they cancel, and I get a negative 3. I have a negative times a negative, and half of 6 is 3. So I get a negative 3, a positive 3. That does give me 0. Half of 8, excuse me. I'm saying it wrong still. A fourth of 8 is 2. That's a positive 2. Half of 4 is 2. That's a negative 2. 2 minus 2 is 0. And then I have a fourth of 8, which is negative 2. And a half of 6, which is 3. 3 minus 2 is 1. Guys, I know that was kind of confusing if you needed to jot those numbers down, but I was just doing the matrix math right here. I did get 1, 0, 0, 1. I still have to multiply that by xy. We'll do that in a second. I'm going to do the work on this side. All right. Negative 3/8 times negative 8 gives me 3. Half of 0 is 0. 3 plus 0, 3. Negative 1/4 times negative 8 gives me 2. Half of 0, 2. So 2. Again, if you're unsure where I was getting at, I was just doing the multiplication over here. I didn't write my work. I was just thinking in my head. Please feel free to write down that work if you need to. On this side, I can't have two things. I can only have one. So this is really weird. Guys, the identity is like the number 1. This multiplication here is actually going to give me xy again. Because what's 1 times x? X. What's 0 times y? 0. What's x plus 0? X. The other one, what's 0 times x? 0. What's 1 times y? Y. There was no multiplication to do on the other side. So guys, right now, it kind of looks weird, but do you see how there's a top row and a bottom row? Hey, it looks like x equals 3 and y equals 2. But this is a system of equations. How is our answer always written if it's a system of equations? And so I know it's a little bit different. I know this one was a little bit weird. And sometimes our answers are a little bit strange. But that's how you do it. All right, the next one I am going to do, because you might get things like this on your homework too. Our next one has a pretty big determinant. And so I'm going to work through this one pretty much step for step with you again. And hopefully we get through it okay. So you wrote down the original. Would you please write down the matrix equation? All right. And again, because I'm doing these kind of step for step with you, that's what we would write first. Would you please work on finding the inverse? This one I already have written down just so you guys know. And this one, yes, as you're working on it, has a pretty ugly determinant. Now, I know I said before that some of these reduce and can simplify, but 1/27 isn't really all that nice. So this time, and I know it sounds funny, but that's why I wanted to do this example as well. This time, I would recommend leaving the 1/27th out in front. But that does mean I'm going to get bigger numbers for just a second. But I promise you they're going to work themselves out. I 100% promise you they are going to work themselves out. Okay? So if you found the inverse, hopefully that's what you found for the inverse. And that 1/27th is kind of ugly, so I'm going to leave it there. Since 1/27th is kind of ugly, I'm going to leave it there and I'm going to do some work with this. I am going to have my calculator out because these numbers get a little bit bigger. And so I get -3 times 6, -6, which gives me an 18. But then I get 1 times 9, which gives me a 9. Interesting that the first number I found was a 27. Next, I'm supposed to do -3 times -1. That gives me 3. But then I have 1 times -3. That's -3. 3 minus 3 is 0. -9 times -6. That's a pretty big number of 54. But then I get a -54. That's a 0. -9 times -1 gives me 9. -6 times -3 gives me 18. Oh my goodness, guys. Please, please, please realize if you find the inverse and you multiply the inverse and the original, even though I don't quite have it yet, what if I would distribute this 1/27th? All right, so I'm going to get 1001. Please, if you are doing the inverse and you do not get 1001, go back and check your work. And then, guys, this is real quick. What's 1 times x but 0? And what's 0 and y? So I know I did that really, really fast, but that's because that is actually how this half would work. This time I'm going to have to do a little bit of work here, and I still want that 1/27th out front. So what is -3, guys? I'm using my calculator too. -3 times 18 is -54. 1 times 27 would be +27. -54 plus 27 gives me -27. Oh, how convenient. With having a 1/27th out front. Let's see, -3 times 18, right? Times 18 is -54 plus 27. Okay. Oh, that 27 was negative. Sorry, that negative. I knew something was looking not quite right here. I forgot to copy down a -27, so I have -54 minus 27, so that should give me -81. That looks better with what I know I'm supposed to get, guys. All right, -9 times 18 gives me -162. Now that I have that negative there correctly, -6 times -27, gives me a +162, so that equals 0. All right, sorry I was hung up there for a minute, but this 1/27 has to be distributed. So what's -81 divided by 27? -3. And anything times 0. And so it looks like my answer on this one, sorry I got hung up there for just a second, guys. It looks like my answer on that one is -30. So I wanted to do that because on example 1, I distributed the determinant and we could work with it with those fractions. Those numbers worked out a little bit strange. Here your numbers were bigger, but when we distributed the 27, things worked out okay. So anyway, guys, that's inverse matrix. I know it's a little bit weird. I know I only did 2 examples, but remember you can go back and repeat and watch them again. I would recommend maybe doing that. I am available if you have questions. I know with your class being in the afternoon, people work more in the evening. If you need to reach out at me at the evening, I'm probably going to be at home. I think it's supposed to be pretty nice on Thursday, and so I'm probably going to take a bike ride. But if you need to get a hold of me, try to email me. I'll let you know when I can get back to you. If it's the afternoon after school is out. But I hope you do okay on this, and it's only a few problems. For the 3x3, and the reason I'm saying that, if you look at the homework, I already gave you the inverse. I didn't tell you how to find the inverse of a 3x3, so I gave you the inverse. I want you to see if you can take what we did and apply it to a 3x3 if you're already given the inverse. All right? I hope you have a good day. Miss seeing you guys. Bye.